for that. So yeah, today we'll go over things that you guys have big questions on when it comes to the things that we're going over for math. And so anything that pops in your brain that you guys really want to go over, and then we can kind of go that route. And then we'll do that. And then if we have time, we'll obviously take on some additional things too that may come up as well. And then if there's additional things, we can also discuss that tomorrow as well. So if you'll be there too. So we'll start with going over things that you guys may have struggled with in the previous weeks.
I'm sorry to interrupt. You said tomorrow as well. There's another Zoom tomorrow.
Oh yeah, so that's for our crash course. So thank you for clarifying.
Gotcha.
So yeah, for our crash course. So those of you guys who are in the crash course, we'll go over those additional things tomorrow. But for the purpose of today, so yeah, we can go over things that like pharmacology aspects of things and anesthesia, things that we've kind of covered so far. Let's jump on those kinds of things. And then, of course, if we haven't got into if we got into all of your questions there, we can kind of jump onto the additional things that we'll probably cover tomorrow, like ECGs, calculating heart rates and stuff. But if we get to that today, that's awesome. Otherwise, we can do that, at a different time too. So, and also too, for those of you guys who are on VTNE prep so far, there are additional math videos if you haven't been able to look at them yet. There are videos for math that I've done previously that may help you too with other people that go over like all of this stuff as well. So definitely check those out. And I do some of these quite frequently throughout. So it seems like math is quite a big subject. So we'll definitely cover those. So let's start with what subject you guys want to talk about first? What's the biggest struggle so far? I feel like it's CRIs.
Yes.
Yeah.
CRIs. Yeah. I was like, I'm gonna guess what CRIs. And I'm so glad that I get to see my favorite person here right in the front with CRIs, right? So who is that? There's Jatara, right?
Yeah, I cannot give them, but I have faith. I have faith that you're going to get me there.
Great. Yes. So our CRIs. So what I'm going to do is I am going to copy a very long problem.
Sorry, by the way, I couldn't change the name. It has my daughter's name.
Oh, you're fine.
Okay.
Don't worry, I recognize you. You're fine. Let's see. Let me see if I can copy this problem, and then what I'm gonna do is I'm gonna paste it into my I don't want that. You guys know how I am with technology. All right, so now I'm gonna share my screen so you guys can see my Word document, and then we'll get to starting our problem that I'll have for you. Look, I can't even spell over here. Look at that. All right, so our problem. So this is going to be a lengthy problem, but this one should hopefully help you guys with CRIs. And we're only going to tackle one drug in this one. So hopefully you guys kind of understand it a little bit better, and we can always go to another one that has additional drugs in it. And then, you guys who are in the crash course this next week coming up for surgery, I put additional math videos in there for you guys to help with some of these CRI ones in there too, by like David Liss and Megan Brashear and stuff in there as well. So, these additional people, they always have something extra in there, maybe a little different pizzazz in there that may help with just explaining things a little bit different. So sometimes it just takes one different person to make you understand it. So I'm just going to read the problem first, and then we'll kind of tackle these steps one by one. So, and granted, I will tell you this, the VTNE will not be this complex, okay? So don't fret, it won't be this bad. But it's good to know in case you guys are in practice, so that you know exactly how to do this. All right, so a 50-pound Australian Shepherd will be prepped for a TPLO, and the surgeon asks you to prep a fentanyl CRI with a loading dose. So loading dose just means just a bolus dose that we're going to give right away, and then we'll start the CRI. So the infusion rate is 2.5 micrograms per kilogram per hour, and the concentration of fentanyl is 0.05 mg per mil. So usually when I'm reading the problem, I just kind of go, whatever the dose is, you know, I don't get like worried about that. The loading dose is 5 micrograms per kg, and your department places the CRIs in 500 ml bags of plasma light. Okay, so we're not using a liter bag, we're using a 500 ml bag. Your surgeon would like the fentanyl to run over the next 24 hours. So they want it to go for a whole day. They're so nice. Pain meds for 24 hours. All right. So the first part of our question here is, how many micrograms of fentanyl would you add to your 500 ml bag of plasma light? Okay. So we have to digest all of this information and then just pick out what we need out of it, right? So it's just asking, how many micrograms would you add to your 500 ml bag? All right. So we know that we want this to be for 24 hours, and we already know that our dose is right here, right? So do we know exactly how long our bag is going to last?
No, so we have to figure that out first, right?
Perfect. Yeah. So we would need to figure out, okay, so how the surgeon would like to run the fentanyl over the next 24 hours. So they want to put all of that fentanyl, right, in the bag for 24 hours. So do we really need to know, though, how much we are running our fluids, though, during that time? If we're just going to put it all in the bag of fluids?
No.
Correct, yeah. So essentially, in this case, right, we're just diluting it down so that we can give it in the bag of fluids, just like to give it over 24 hours, right? So we could, and in some of practices, we could just give it with a syringe pump if they really wanted to, but we are putting it in a bag of fluids, essentially. So we'll determine, honestly, what the fluid rate will be for this patient based on 500 mils divided by 24, if that makes sense, right, at the end. So that's probably.
So it's because normally they would give us a fluid rate, so we have to figure out the fluid rate ourselves in this problem. Okay.
Yeah. So I know I made it really tricky. So what we're going to do, though, is we are saying, okay, this bag of fluids is going to last for 24 hours. So we're going to figure out our dose for the 24 hours that we're going to put in this 24-hour worth of bag, right? So I know I made it really hard on you. Oops. I'm just giving myself some room here. All right. So here we are just taking our dose. Sorry. You know, gotta talk to everybody. All right, so we are gonna take our dose, 2.5 micrograms, right? And then we're gonna multiply that by What is our kilogram for this guy?
22.7.
Perfect. 22.7 kilograms. And then we know we're going to be doing this for 24 hours, right? So 24 hours. So if we put that all together, how many micrograms do we have?
1,362.
Perfect. So micrograms at the end. So that's how much we need in our whole bag. All right. So if we break this down now, it says how many mils of fentanyl will we need to put in our 500 ml bag? So if we take our 1,362 micrograms that we have, right? And what is our concentration of the fentanyl?
And 5 mg per mil.
It's 0.05 mg per mil, right? Oh gosh, now we have to do something with that, right? So, well, how do you want to go about doing this? Do you want to change our current micrograms that we have here to milligrams, or do you want to change the fentanyl to micrograms? Either way is fine.
Micrograms to milligrams.
Micrograms to milligrams, yeah. We all like micrograms or milligrams better, right? So how do we do that? How many micrograms are in a milligram? So
1,000.
1,000, right? There's 1,000. Sorry. So there's for 1 milligram, there's 1,000 micrograms, correct? So we'll divide out your micrograms. For those linear people, I'm not a linear person, so I kind of suck at that. So that's how we're going to figure out what we get for milligrams. So how many milligrams then do we have?
Beth, I have a question. This might be a slow question, but the microgram, the MCG is interchangeable with UG, right?
Correct.
Okay,
Yeah.
because it kind of threw me off with the.
Oh yeah, very good.
Yeah, that throws me off every time too. I have to really think about it.
Mm-hmm. Absolutely, good question. So from here, what do you guys get for our milligrams?
1.36 milligrams.
1.362 milligrams, perfect. And so what do we do with our concentration then, since now we have the same units? So if we're looking for milligrams, right, we need to, we are going to need to say, okay, there's someone in my chat. I always forget my chat. Oh, it's not showing. I must have, hold on. Divide, perfect. Divide by 0.05 milligrams. Thank you. Here, I'll move my chat over so I can see you guys. Okay, so yes, you're gonna divide by 0.05 milligrams, okay? So you're dividing by 0.05 milligrams, all right? And it'll leave you with mils, okay? So what do we have then?
27.24 mils.
Good. 27.24?
24.
Okay, 24 mLs. Perfect. So, and you can just say 0.2 because that's what you can draw up. That's totally fine. But that makes sense because that's for a whole day. So you're drawing up that whole day's worth of drugs, right? And then you'll put that into your bag. Awesome. Very good. So does that make sense to everyone so far?
Yes.
Yeah.
Awesome. Good.
Yes.
All right. So now we can't see all this, but that's okay. Oops. Okay, so what should your total volume be in your CRI bag after you add your fentanyl? So this is a trick question. All of my crash course people should know this.
500 ml.
500 mLs, good. So you should only have 500 mLs in there total after you add your fentanyl, right? Why is that?
So you have to take out what you add in.
Good.
Keep the same amount.
Correct. So you should only have 500 mL. So you take out the 27.2 mLs of your, what are we using? Plasmolite. Okay, you take that out. And then you put in your 27.2 mLs of fentanyl. So this is really important, especially, so this may not be super important, right, for this case, right? But it would be really important if you're doing, you know, percent of dextrose or percent of, you know, calcium gluconate or something, you know, high in percentage. So we should just get in a really good habit of taking out what we're putting in. Everybody understand that part?
Yes.
Awesome. Because you guys are going to be my leaders in the field.
Question,
Yes.
maybe it's a really late question,
Yeah.
but at your question A, you have your 2.5 times 2.2, and then is it times 24 or is it divided by 24?
Times by 24. Yeah.
Thank you.
Yep. All right. So we kind of got this one a little bit earlier, but we didn't get a fluid rate out per hour. But what would be our fluid rate that we would run our fentanyl CRI? So how do we set that up? I love that you have your cat, Molly. This is great.
Oh, sorry.
No, it's great. I love it. Tara told
He
me
likes
she's
to
gonna
help me
have her
stay.
animal, so
Yeah,
Mine are
mine's
all
laying
gone.
right next to me too.
yeah, mine
He's
like
next to
left,
anybody.
and I have like a whole ton of animals, and they are all gone. Okay, so our fluid rate would be, so we're starting out at 500 mils, and then what do we do?
Would you just divide by 24?
Divide by 24.
Yeah. I know, super simple. Our doctors are going to tell us these crazy things like, okay, I want you to do this. And you're going to be like, oh, but it's really not as hard as it seems. So divide by 24 hours. Sorry, I have really horrible handwriting, but I'm writing like this on a screen. So, okay, so 500 divided by 24 hours, and you get what?
20.8.
Perfect. 20.8 mils per hour. Awesome. So we're going to hold on to that for now. I'll table it.
Then would you round that or just leave it?
So it's not horrible, right? It's not going to matter too much, especially since it's super diluted. There are a lot of fluid pumps that can run at 20.8 mils an hour. So that's the nice thing. But it's not going to matter too much in that case. So that's the nice part, but I would leave it for now. If like you have a fluid pump that doesn't, do that, then you can obviously round it. Okay, so the loading dose in mLs. So we need to figure that out. And then when and how is the loading dose given? So we can, I guess let's answer that. When and how is that loading dose given?
Would it be prior to starting the CRI?
Good. prior to starting it, and then how are we going to give it? So it's fentanyl.
Oh,
Ouch.
What is fentanyl?
an opioid.
Opioid.
It's an opioid, great. It's a pure opioid, pure mu opioid, right? It's a very strong opioid.
Analgesic.
Mm-hmm. Yeah. It's very, very strong, right? It's like 100 to 250 times stronger than morphine. So it's pretty potent.
Yes.
Yes. Great. So how would you give it?
Give it IV slowly.
Give it IV semi-slowly, right? We don't have to like bolus it super fast, but we could give it over a minute or two. That's totally fine. And it's short acting, so that's why we give it as a CRI. So it's not going to last like hydromorphone, where it will last 4 to 6 hours, or same thing with buprenorphine. It needs to be given as a CRI. So perfect, good. All right, so our loading dose. So we found our loading dose, which is right here. And so that is 5 micrograms per kilogram. So we need to figure that out as a mils that we're going to give. So again, we're going to have to convert that at some point to milligrams so that we can get the mils at the end. Okay. So how are we going to do that? How are we going to do this problem?
Divide by 1,000.
Divide by 1,000.
Oh, you
Yeah.
want to get rid of it right away. Good.
Yep.
Okay. So you could do that. Yeah, you could do it either or. Perfect. So you're like, okay, micrograms are gone. So we go micrograms, 5 micrograms, divide it by 1,000. Bye. And we're going to get milligrams. So what do we have? It's going to be a super tiny small.
0.005.
0.005. Oh my gosh, my handwriting's just awful. 0.005. Okay, so our new dose then is 0.005 milligrams per kg. Okay. So that makes people a little bit more happy, right? Because they're like, oh, milligrams now. So now we can input our milligrams per kg. So 0.005 milligrams, and then times our kilograms. So our kilograms was 22.7 kilograms, right? So what would be our
0.11.
it would be 0.11 milligrams.
Mhm.
Okay, perfect. So 0.11 milligrams. And then how are we going to figure out our mLs that we're going to give?
You then have to divide by the 0.05 again.
Good. Yeah, so we're going to divide by the concentration. So that was 0.05 milligrams. That's the concentration. And that will give you the mLs that we're going to give this patient as the bolus. So 0.11, divide that by 0.5, and you get
2.2.
2.
You said 2.2?
Yeah.
2.2, good. mLs, perfect. Awesome. All right. So now that we took a break, I guess, from our question there, we are going to go back to our fluid rate that was up here. So the 20, oops. So we're going back to this right here. And we need to figure out drips per second. So say we don't have a fluid pump available, which is, believe it or not, there are practices that don't. So we have to do a drip set or a drip rate. So how are we going to figure out our drip rate for this guy?
Isn't it, since he's larger kilograms, it's 15,
Good.
like per liter seconds?
Yeah, very good. So our macro sets, right? The macro sets are 15 drops per mil, and then micro sets are 60 drops per mil, right? And so if our patient is over 7 kilograms, so if they're greater than 7 kilograms, we're going to go with a macro set. Okay. Now, if they're less than 7 kilograms, we're going to go with a micro set. Okay. So that's how we kind of configure it. And so just like you said, we can look at our 50 pounds and realize that he's over 7 kilograms. So we will take first our 20.8 mLs. All right. And kind of a way how I make it a little bit easier is we have to convert our hours into seconds, because at the end of the day, we have to figure out drips per second, right? And so how do we figure out, how do we make an hour into seconds? How many seconds are in an hour?
The trivia quiz.
3,600. Of course, you guys know. So if we figure out here, oh goodness, maybe I can scroll up my screen there. Like you guys are seeing like craziness. So 3,600 seconds. So essentially in an hour, there's 60 minutes. And then in each minute, there's 60 seconds. So if you multiply those together, that would be 3,600 seconds. So when you figure out your drips per second, you just convert that hour into seconds. And then your next multiplication part is you just have to put in your drip set, which you just figured out was the macro set. So for this guy. So we're just going to put in our 15 drip per ml. And just like you stated, we have crossed out our mils here, and it leaves us with drips per second. So we know we've done it right, correct? So now we can just do our math part. This is probably the worst handwriting I've ever had.
So 2,596 drops per second.
Let's see, 20.8 times 15 divided by 3,600.
Yeah, I did that backwards.
Okay. So we got
0.08.
perfect. 0.08. Yeah.
Beth, can you scroll your screen up so that we can see the top question?
Yes.
All good. Thank you.
Yeah. All right, so. All right, so you guys know we can't leave it this way, right?
Right.
Okay, so we have to make it a whole number, right? Because we can't do micro drips in a, we aren't that good. So how are we going to make this a whole number?
Multiply.
Add it to the nearest whole number per seconds.
Yeah, multiply by some number of seconds, right? So we're trying to add additional seconds to it essentially, right? So so what is a second that we can be close enough to that's going to get us a whole, at least a whole drop, or you know, some sort of drops?
13.
13. Okay, I got 12, but maybe that's okay. I mean,
Mine was a little over, but
yeah, mine was like 1.04, so we're probably just really close.
How
So-
did you get that? You multiply 0.08 by 12?
Yep. Yeah.
I got 0.96.
0.96. Okay.
And then when I did 13, I got 1.04.
Yep, that's what I got.
Okay.
Yeah.
So how do you figure out what that is? Is it you multiply it by the highest number that will give you at least one drip?
Correct. Some sort of whole number, right? So sometimes you'll get a number that you'll have to multiply by, and you have to get a whole drip. So sometimes it'll be like 5 drips per 4 seconds, you know, but you have to have a whole number. So that way it's not like 3.5 over 2 seconds, if that makes sense. So it's all about playing with fractions and kind of trying to know fractions and decimals. Like, I don't know when we learned that. Oh gosh, that's a long time ago in elementary school. Don't make me go back to that. And so, yeah, just trying to play around with your calculator on those guys. You get used to it over time, honestly, when you get back into practice of things. And if one doesn't work, you're really close to another. So if like 8 seconds doesn't work, then you're like, bet 9 seconds probably works, you know? So you get close to it. What did we say? 12 seconds, 13 seconds?
13 seconds.
13?
But like, it gave me 1.04. Would you just
Yeah,
like
we can call it that.
focus on the 0.4? Like,
Right. Yeah, because otherwise we'll be like, oh, 8 seconds over 100, or I'm sorry, 8 drips over 100 seconds or something ridiculous, and no one's gonna stand there for that long. So that's totally fine. Perfect. Yeah, it has to be just at least as close as humanly possible. So
Okay.
in a practical setting. So so 1 drip per 13 seconds. So we'll just say that. Perfect. So as long as you guys are kind of good on that, it does take practice. So just keep practicing with those problems, and truly, as long as you know how they're worded, you can just make up your own and go from there. That's kind of what I do. Sometimes I get wonky. I will say I've given people wonky questions and I'm like, I'm so sorry. So considering that this patient is having surgery and knowing what a surgical fluid rate is, right? We have to balance these fluids, right? So the patient's 50 pounds. And so he's 22.7 kilograms. What is surgical fluid rate?
5 ml per kilogram.
Good, 5 mLs per kilogram per hour.
if it was a cat, it would be.
It would be 3. Good, very good. So what is our total fluid fluid rate for this guy that he can have. Oh, no, a dog, I love it.
Sorry, she was crying. I don't want her.
I like it. Oh, perfect.
113.5.
So I'm sorry, 113.5. 113.5. Okay. 113.5 mLs per hour. Awesome. So that's the total that this patient can have for surgery time. So what do we do in that meantime?
I have a question. Is it okay to round it up?
Sure.
Okay.
Yeah. If you don't have like a pump or something that is going to be exact, like that's fine, especially when they're 113, you know, we have a bigger dog. Now, granted, if you have like this little patient, you know, and they're on like 5 mils an hour, you may want to see if you can, you know, not round it or, you know, just based on patients. But yeah, no, when it's like 113 mils, you're fine. So, and there's some pumps out there like those Heska pumps, the little square Heska pumps. They don't even, once you get to like 100 mils, they only go 110, 120. So you have to pick which way you want to go. So you can't even get to 113. So, which is frustrating. Okay, so we can only give 113.5 mils total. So what do we do with our fentanyl CRI? And our other fluids that we want to give.
Just subtract a fluid to replace it with another fluid.
Yeah, very good. Yeah, so we're gonna have to balance them out. Good. So we'll take our make sure I get it right. Okay, 20.8 mils an hour that we're gonna do of our fentanyl CRI, right? And so we're gonna do 113.5 mLs and subtract the 20.8 mLs of the fentanyl CRI. And that will be our new total of our just plain fluids that we're gonna do. Now you guys are gonna be surgery techs tomorrow. You got, look, Shar just gave me this look like, nope. No, she's writing. I can tell she's writing. Janice isn't here, so I can't give her a hard time, so. So we have
92.7.
92.7, great. So 92.7 mLs of plain, oh gosh, I should write 92.7 mLs per hour of plain fluids of whatever they decide. And then 20.8 mLs per hour of our fentanyl CRI. And that's it. Look, we just spent all this time on one problem.
So essentially for 1 hour, it would be getting the 20.8 mLs of the fentanyl CRI because that's the time frame for that. But for the rest of the surgery, it would be on 92.7 mLs of, like, say, LRS, if that's what they wanted to do.
Yeah, so concurrently, so at the same time, this patient would get both of these fluids. So in total, this patient would then get all of the 113.5.
Gotcha. That makes sense.
Yeah. And then when he goes back to the ICU or wherever recovery, remember too, this guy would then go on to like a maintenance fluid rate. So we would then calculate out maintenance fluid rate and put him on maintenance on top of the fentanyl CRI too, and then subtract that. So that's why it's really important that we know how to do maintenance fluid rate and then subtract the fentanyl CRI. And so again, this may not be necessarily what's on your VTNE per se, but first day on the job, these are things that you guys learn. So now some of these things definitely, like, you know, knowing how to do CRI calculations could be on your VTNE, but it's really good to also have a good idea and concept of how to take that step and put it in form that you can transfer into how to do it on the job too, and kind of get that picture in your mind, like, okay, I can do this, you know, because I know you guys can do it. It's not that bad. So does that make sense to all you guys? You
It
know
does.
the formulas, you know how to do it. So it's just practice. So, okay, let me see here. Let me,
Hey, Beth,
I'm sorry.
can I ask one question about that CRI?
Yeah, absolutely.
So how are you adjusting that if you need to adjust your CRI in surgery? Because sometimes in surgery, we need to increase our fentanyl CRI. So we always dilute ours for 1 microgram per kilogram equals the 1 mil per hour. How are you adjusting your bag like that?
Yeah, so for that bag, they could increase because it's already set for 2.5 micrograms per kg per hour, they could then increase the fluid rate itself.
Okay.
And then they could increase the fluid rate itself and then adjust your plain fluids and bring those down. And then, vice versa. So
Okay.
that's a really good question. Now, I mean, that is where we have to then be cautious with fluid overloading and that kind of thing too, which I, of course, it depends on the doctor because that's where we play with syringe pumps and stuff like that as well. I mean, I totally do like my syringe pumps. Yeah, that's a really good question that we utilize too. But yes, when they came up with their dose of the 2.5, that's how they came up with that. You can also, of course, add additional if you need to, but no, you just adjust the fluid rate from there. All right, what else do you need? Oh, this one might be good. Oh gosh, I think I might. All right. If I can improve on my writing skills. I have another problem for you. Maybe. All right. Okay, let me share my screen again. Okay. These guys didn't wanted to stay with down here, so I was gonna have to move. All right, so your doctor orders a 50 microgram per kg per minute of metoclopramide IV, and your patient weighs 68 pounds. Your patient's fluids are running at 105 mils per hour, and there are only 630 mils left in the bag of Plasmolite. Metoclopramide's concentration is 5%. How much volume of metoclopramide will you add to your bag of fluids? So I did this on purpose to make you guys work on concentrations, or I'm sorry, conversions. So this is kind of my typical problems for you guys. So where do you guys want to start first?
Pounds to kilograms.
Pounds to kilograms, good. So where do we want to go? $68 divided by 2.2. What is that?
30.9.
30.9? Okay. Great. Perfect. What is our next step you want to do?
Well, we need to divide the 630 by the fluid, what it's running at.
Okay, so you're looking for time, right?
Yeah.
Okay, so we need to figure out how much time we have left in our fluids. So we have 630 mLs left. And our fluids are running at 105 mLs per hour, right? So if we divide those out, how much time do we have for hours?
6 hours.
6 hours. Wow, it's like someone did that perfectly for you. So you have 6 hours left. What do you need though?
Minutes.
You need minutes, right? So how do we figure that out?
Divide by 360.
Multiply by
Oh, we gotta chat. We gotta chat.
Minutes times 60.
Yeah, times 60. Ooh,
360.
Becca's here. Oh, but Becca's been playing stuff too. 60. Good. It's 360 minutes. Awesome. So perfect. So now we have minutes. So look, we can totally fill in this whole thing for metoclopramide. How beautiful is that? So metoclopramide, I'm just gonna put metoclopramide. So we have, do you want to leave it as micrograms for now? I don't really care either way.
Sure.
Yeah, because we're gonna have to change anyway. So 50 micrograms, right? Times our 30.9 kilograms times 360 minutes. Look at that. We figured it all out. Easy peasy. I like write like a kindergartner when it's sitting up. So what do we have for that?
$556.2.
556.2 micrograms. I was like, that is a big number, but then I realized it was micrograms.
Oh, no, I'm sorry. Wait, I converted mines. I converted mines to milligrams. Sorry.
Oh,
So that's probably not right.
Okay.
So non-converted would be 556,200.
Wow, 556,200. Jesus, micrograms. Okay, and then to convert it, we divide by 1,000 micrograms. Oh, geez. Okay, and then it's
56.2.
56.2. See, this might be one of those where I was like, oh, Beth, what did you do? Okay, perfect. So now we have our milligrams that we want. Look at you jumping ahead.
Sorry, it's easier for
perfect. It's perfect. I love it. Okay, so now we have to figure out metoclopramide as a percentage, which some of you know how I am with percentages. So, how do we figure, or I should say, what does percent represent?
Grams per 100.
Grams per 100 mLs. Yeah.
Oh yes, I love you all. So the percent represents grams in a solution over 100 mLs. So that means that whatever is in there is, I'm like pointing at it. Whatever is in there is that there are that much grams of that medication in 100 mils of solution. So not just adding a 0 to it, but that there's actually substance to this. There's a meaning to it. Okay. You guys are so great. Thank you. Now, when you're in a practice, absolutely add your 0 and get it done. That's totally fine. But just remember in your brain that that's what it means. It's great. Okay, so what are our milligrams then for our percent solution? Here. 5, right? So here we can just remove that decimal and it becomes 5. So if it was 2%, it'd be 20, right? If you want to do the long way, you could just say, okay, it's 0.5 grams, and then you do the longhand math. That's totally fine too. So then we take 556.2 milligrams and we divide that by 5 milligrams. Oh, wow. Remember when I said I screw up problems because I just insert numbers? That's what I did here. So how much metoclopramide would we add to this bag?
11.12.
I'm sorry, I might have missed something, but earlier you said that if it was 2%, it would be 20, but now that it's 0.5, it's 5.
Yes.
Yeah, I'm a little confused there too.
Yeah.
So, okay. So if you have 0.5 percent, I should say, I'll start there. If you have 0.5%, that means that you have 0.5 grams in 100 mLs of solution. Okay. And so when you break it down, so that means that you will, to get milligrams here, you multiply that by 1,000, right? To get milligrams. So that would be 500 milligrams per 100 mLs. Okay, so we're just simplifying everything. So to simplify it even more, we just cross out all the zeros that we can. And so that leaves us with 5 milligrams per mil, kind of what we have here. So if we had 2%, right, we would have 2 grams over 100 milliliters. And so it would be 2,000, because we multiply this 5,000 for milligrams, 2,000 milligrams over 100 mLs. And so we cross out those zeros and it leaves us with 20 milligrams per mil. And so a lot of times in school, what we're taught is that, you know, if you're given a percentage, to just add a 0 or multiply by 10, right? So that you get 20 milligrams, or here 0.5 times 10. Yeah.
I see.
Yeah. So I just want you guys to know like where it comes from, because you'll see it even on the bottle that you get. It'll say like 0.5 grams per 100 mLs. And so you should understand what that means. Plus on the VTNE, you could see that it's not in a total simplified form. You might be like, it might say like, what does this equal? And it could not be a simplified form. So
amazing. Thank you. Sorry.
yeah, no, of course. No, you should ask questions. That's great. Okay, so we got here. What is the answer? What is the horrible answer that I gave you? It's something ridiculous.
11.12, I think.
11.12? Really?
111.2.
Oh, 111. Okay.
Yeah, I did that wrong.
111.2. And I was like, did I mess up? Okay.
Yeah, I did by 15s too.
Oh, okay. I was like, that would probably be better because my answer is awful. Perfect. You'll never have that for metoclopramide in the bag ever. Perfect. No, that's great job. Look at that hot mess of math right there on the paper. My poor teacher is having to grade my papers. They probably like never knew how to grade it. All right. Does that make better sense on CRI? Maybe?
Yes.
Okay. What is something else that you guys want to go over? Anything?
Can we go over problems that are, for some reason, the mill equivalents throw me off?
Yeah.
Thank you.
Yes. Great question. So mill equivalents are so funny because, oh, I have one right here. They're so funny because they're really simple. And it's only, I think, because we trick ourselves a bit. All right, let me share my screen again for you. Oh, look, everybody's like, mill equivalents, yes. Everyone concurs. All right, so look, this guy's like, seriously, like, wants to hang on for dear life. Okay, so I think, yeah. So if KCl is labeled at 20 milliequivalents per 10 mils, how many mils would you add to a 673 mil, add to 673 mils, I guess, of fluids? If a DVM ordered 46 milliequivalents to KCl per liter, okay? So think of milliequivalents as, people say, as just think of it as milligrams, essentially. It's just a different measure of drug. It's not milligrams, right? It's not. But the reason why it's milliequivalents is because this is an electrolyte. So that's the reason why that is in the form of milliequivalents. And so long story short, I mean, I could go into why it's called milliequivalents. But when you are looking at it like potassium chloride or potassium phosphate, there are certain drugs that are just measured as milliequivalents. So many times people get just stuck up with the milliequivalent aspect of things, but it's truly very simple, like if you were doing it with milligrams instead of just milliequivalents. Okay, so when we look at this, if you see that and I'm just gonna move that down there. Your doctor orders 46 milliequivalents of KCl per liter, right? So look at this as, hey, my doctor wants 46 milliequivalents in a whole liter. How much is in a liter in milliliters?
1,000.
1,000, good. So if this is 1,000 milliliters, let's figure out how many milliequivalents that your doctor wants in 1 ml first. And I have a method to my madness, I swear. So 46 divided by 1,000.
0.046.
Good. 0.046 milliequivalents per ml is essentially what your doctor ordered, right? Yeah. But
How did you get that number?
So I essentially took 46 milliequivalents KCl and I just divided it by the 1,000 mLs that your doctor ordered.
Oh, okay.
Yeah. Yeah. Because we don't have 1,000 mLs. So, but what we do have is 637. So do you see where I'm going?
No.
No? Okay. So now though, we have a dose that he gave us of per mil. So now we can multiply this by our 630 or 673 mLs. I think I was saying the wrong thing. So we can get a dose. We can remake his dose.
So you did 46 divided by 1,000,
Mm-hmm.
and then that gave you your 0.046,
Correct.
right? And then you did, oh, that's where you got your 673. You did times that. Ah, gotcha. Okay.
Mm-hmm.
So 30.9.
Perfect. So 30.9. So our new dose is 30.9 milliequivalents of KCl per the 673 mLs, right? That's what's needed. Awesome. Good job, Jeannie. Okay, so now our next part is to figure out concentration, right? So we know how much MEQs we need in our leftover bag. So how many mLs are we going to put in that, right? So what's the concentration of KCl? Of course, if anyone's used KCl before, they do this on the package, put 20 milliequivalents per 10 mLs. And if you guys just saw me do what I did with the grams over 100 mils and then kind of like the milligrams to 100, you can just do this. So the 20 milliequivalents, right, over 10 mLs. Oops, 10 mLs. There's zeros on the top and the bottom, right? So you just cross it out because it's not in a simplified form, right? So the real concentration of this guy as well is 2 milliequivalents per mil. Does that make sense? Awesome, Andy. Yay.
So you did 30.9 what? Then divided by 673?
So we're not going to divide by 673. That's just saying that our dose that we need for the 673 is the 30.9 milliequivalents of KCl. Okay. So we don't need this right now. Okay. We're just going to be using this.
Okay.
All right. So our concentration for KCl is 2 milliequivalents per mil at the simplest form, right? Yay.
Yep.
Awesome. So what are we going to do? We're going to take 30.9 milliequivalents of KCl. And what are we going to do?
Divide it by the 2.
Good. Divide by 2 milliequivalents. And we get
Where does your 2 milliequivalents come from though?
it comes from this concentration here. And we just simplified it.
Oh, so instead of putting 20, you put 2.
Correct.
Is that it?
Yeah, we
Okay.
simplified it from the 20 per 10. We just simplified it to 2 per mil. Hannah got 15.47. So we could do 15.5. That's fine. So 15 mils. And
Would it
remember, we're going to take out and then put in, take out what we're putting in.
Would it still work if you would leave it at 20 instead of 2?
No. Because if we divide by 20 here, we're going to come out with a much smaller answer.
Which would be 1.545.
Yeah. So we have to simplify our concentrations to each ml. So that's why we have to be really careful when we're looking at concentrations and making sure that they're totally simplified. So can we treat the 20 milliequivalents per 10 mils like the percent concentration? So yes, you absolutely can. Absolutely. Like to solve. Yep, absolutely. You just have to simplify it. That's all. Yep.
What would happen though if it would be like, say, 22? How would you simplify that? Just drop it.
2.2.
2.2?
So if it was 22 milliequivalents per 10 mLs, you just simplify it to 2.2. Yep.
Interesting.
There are weird ones like, oh gosh, I think potassium phosphate is like 4.4. So yeah, I mean, they come in all different, and like atropine's weird. Like there's some weird ones out there that you have to, you know, epinephrine's weird. So, so yeah, you just have to be able to do your math. I mean, on some of them, they're all not easy without doing calculator action, which in emergency, sometimes I like to not have to use my calculator because I don't have a lot of time. So, does that make sense for everyone?
So you could do 2.0 then. That
Yes.
would give you 15.45.
Yep.
Okay. Cool.
Milliequivalents is not as scary.
Could
Nope.
we do another problem like this?
Like that? Yeah.
Yes.
Yes, please.
Yeah. Let me find one. Oops. Let me find one. Oh, goodness. You guys are so funny about these milliequivalents. I love it.
I understand it when I go over it with you, but then when I try and do it on my own and put it in VTNE mode, just the pressure of the time, that's when I make the mistake.
Yep.
I have the same problem.
It's so funny because it is literally the same. I mean, everyone says the exact same thing, and I probably would say the same thing when I was in your guys's position too. So I totally understand. It just is one of those things where one day it clicks and you're like, why did it take me this long? Like, it's not even that hard. And then you're like, oh well. So let's see where I might have to make one up. I made it.
So Sarah asked, so you take the 20 MEQ and divide it by 10 mils. Yes.
Oh goodness. Where did I go? Oh, I have some really big doozy ones in here. Would it ever do to you?
We should do them because then when we actually do it for real, it won't be as bad.
Oh, some of these are like how to do blood transfusion stuff, and you guys would be like, oh, that's not going to be on the VTNE.
Okay, maybe not that cruel.
I did that one because someone asked me about it, and I was like, you really want to do that? And she was like, yeah, let's do it. I'm like, you're crazy. So, all right, I think I'm gonna have to make one up, but that's totally fine. Oops, I grabbed the wrong one. Where did it go?
Can I share a tip about MEQs when I have to calculate them real fast?
Yeah.
Go ahead.
One way you can kind of double check yourself mentally is like, say you have your original dose of 46 MEQs per 1,000 milliliters, and you only have your 673. You know that your X amount of MEQs is going to be like a little over half, because 673 is a little over half of 1,000 mils. So instead of 30.9, if I ended up with like 309, I knew, that's something wrong because you need it to be less than your 46.
Yep. Wow, I like really wrote this weird. I wrote 2, like TOO. Must have been doing this really late at night. Let's see. I don't want to make it creepy. Oh, let's see. I don't think this isn't even a dose, but whatever. Uh-oh. Somebody is. Oh, all right. Who's chatting? Okay. Oh. Andy's like already gave me a problem too, and I just, that one tripped you up. Okay. Do you want to do that one instead?
Can we do both?
Sure.
I'm
Look at
feeling
you.
thirsty.
Yeah, look at you. You're like, yeah, let's do it. Becca too. All right, let's do that. All right, so here's this one. All right, so potassium phosphate is labeled 4.4 milliequivalents per mil. How many mils would you add to an 847 mil bag if your DVM ordered 52 milliequivalents of KCl per liter? So same approach. I'll let you guys kind of walk through it. What would you like to do?
Do the same beginning.
Beginning, okay. So we're gonna figure out per mil, right?
Mhm.
So it would be 0.052 milliequivalents per mil that we're kind of looking for in our dosing. That we're changing his dose per se, right? And then now we have to put it into our 847 mils, right? So multiply that by 847 mLs.
How would you get your 0.052? Would you
So
divide?
good question. So remember that our liter is 1000 mLs. So we have to take 52 milliequivalents and divide that by 1000. So we take 52 milliequivalents. So I kind of skip that step. Divide that by 1000 mLs to get it to a 1 ml dose.
So 0.01.
So you should get 0.052 milliequivalents per mil.
Oh, there we go. I missed the 0.
Nope, that's good. So then we have 0.052 milliequivalents per mil, and then we multiply that by 847 milliliters because that's how much we have. And so how many milliequivalents are we going to need to add to our current bag?
44.04.
44. Good. Thank you, everyone. And Becca.
Milligrams or milliequivalents?
Milliequivalents, remember, we are.
Thought we changed it to milligrams.
So we're not changing it to the milligrams. We could just treat it like we would with milligrams, right? So these guys are our electrolytes, so we can't change them to milligrams, but we can treat them like if we were as milligrams.
Oh.
Yeah. I know. I wish we could change them to milligrams sometimes. It'd make life so much easier. It wouldn't stress out my students so much.
Well,
So you,
when you divided the 52 equivalent by 1,000, didn't that make it milligrams per milliliter?
No, it still keeps it as milliequivalents per mil.
Huh.
Yeah. So we're just changing the form. We're just changing it to a smaller dosage, right?
Okay.
We're not changing, form.
Sorry.
No, that's
Got
great.
it.
It's a great
Got
question.
it.
Yep, you're a good question. Okay, so we have now how many milliequivalents, right? Look at that, I made it perfect. When I play with numbers. If you guys caught it already. So we have 44 milliequivalents. Now we need to figure out how many mils we're going to add to this bag, right? So how do we do that? We have our concentration, which is right here. And so we are going to do what?
question.
Yes.
For your 44, wouldn't you put 44.04?
Oh yeah, we can.
Okay.
But now
can
you
you
just ruined my perfect number. Okay, we can put
Sorry,
that.
I
just
calculated on my
didn't know. I
calculator, I'm
just
like, wait a minute.
read the 44. So 44.04. Okay. I mean, it's not going to change it too much, but yes, we can do that.
Would it really matter though?
No.
No.
It
Okay.
won't. That's
Sorry.
okay.
Sorry for
Ruined my
ruining it.
perfect number in the end. No, you're good. Okay. So
Would you divide by the concentration now?
yes, divide by the concentration. So we have 44 milliequivalents. And we're dividing by our concentration. So our concentration is 4.4 milliequivalents per mil. So that will give us our ending in mils. So we have 4.4 milliequivalents, right? And we will end up with our mils here.
So 44 divided by 4.4,
Mhm.
right? Gives you 10.
Great. Yay. Becca, Andy, you get virtual candy. That's you.
No.
Today's my daughter's birthday, so like virtual cake. Out to you. With sprinkles.
It's my birthday too.
It is? Happy birthday. Yay. It's the first day of spring, so it's like the best birthday ever. So
It's also National Francophone Day for everyone in the world that
really?
speaks French. Yeah, fun fact. May 20th.
Wow, that's awesome.
Yeah.
Yeah, it's a great day. It was my grandma's birthday too, so it was like super fabulous birthday day. So wow. And DQ, happy birthday. Wow, awesome.
Happy birthday to everybody. Anybody else has a birthday today?
Yeah, really.
Happy birthday.
It was also Mr. Rogers' birthday, just so that you people know.
Oh, I didn't know that.
Yeah, fun fact. Yeah, happy birthday. Very cool. Awesome. All right, let me grab Andy's question here. Andy's question that I trip her up on. Purposely, of course, right? Oopsies, I just screwed that up. I swear. Technology. Worst thing ever. I feel like that didn't copy and paste. Well, it's not copying and pasting. Why? Nope. What if I doesn't want to? Okay, well, I'm just gonna have to tell you guys because it doesn't want to do it. So you're instructed to add potassium chloride to a Now I just lost your chat. Oh, to a 65 ml bag of LRS, so, or 650 ml bag to LRS. So we need potassium chloride for a concentration of, so 35 milliequivalents per mil. Awesome handwriting, of course. The standard concentration of our potassium chloride is 2 milliequivalents per mil. Okay. So how many mils will you add to the 650 mil bag, and then the total MEQs to add, and total volume to add. So we are looking for, our doctor asked for 35 milliequivalents of KCl per liter. We have a 650 mil bag, and that's our concentration there.
So you would remove 37 from 650. If you add up 35 plus 2, can you do that?
So let's try to work this problem with what I just gave you, like this.
So divide the 35 by 1,000 ml.
Good. So we're going to divide our 35 mils, or I'm sorry, 35 milliequivalents by 1,000, right? Because this is in liters. Let's get it into milliliters, right? Let's get it all in the same realm of things, right? So if we divide this by 1,000 milliliters, we will get 0.035 milliequivalents per ml, right?
Right.
Perfect.
Yeah.
So we're like, doctor, we need a different dose because yours is not working for us. It still means the same thing though.
So you did your 35 divided by your 1,000?
Correct.
1,000?
Yep. So that way we get it into 1 mil form rather than in a whole liter. So we're just making it a little tiny dose. Okay. Now that it's in a tiny, tiny dose, we can then say, okay, how much KCl do we need for just 650 mLs? So we can then go, okay, 0.035 MEQs. Ugh, horrible. MEQs times our 650 mLs that we have left equals
22.7.
22.75 on Andy's on 2 MEQs. That's how much we need for our 650 mil bag. And so kind of what Meryl was saying was, all right, if you think about it, our liter bag needed 35 milliequivalents, but a little more than half of our bag, we're on the right track, 22.75, right? It's less. So we're on the right track if we're thinking on a logic end of things. So now what do? We need to figure out how many mLs we're going to put in the bag, right? So what are we going to, how are we going to do that?
Divide by the concentration.
Divide by the concentration, good. So 22.75 MEQs divide by your concentration, which is 2 milliequivalents per mil. So 2 MEQs. And we're going to end up with our mils. Ooh, Jamie, she's on a roll over here. That's because it's her birthday.
11.37.
11.
Oh, yeah.
Let's drop, or let's
11.4.
go with what we can drop, right? 11.4. Awesome. And
I'm starting
so
to feel good about these.
you're on a roll.
Yeah, I feel better.
Great.
Yeah, these are so much easier.
Great. Awesome. This is lovely. So yeah, I mean, I think that we are doing great on that stuff. I think for CRIs, you guys are on a roll too. Again, it takes a lot of practice, honestly. Yeah, we always make them harder than we think. Honestly, we really do. So, and it's just about organizing them in your brain. Honestly, it's like,
Yeah.
and then taking what you need out of a problem. So how I just did it, like taking out the numbers and just throwing them on the page, right? And just forgetting about all the words that are there, sometimes helps too. So, so yeah, you guys are doing great. That's the best thing about it too, is working with each other sometimes helps as well. Great. So I think let's call it a day so we can all celebrate Jamie's birthday. My daughter's birthday as well. She needs to have cake. Megan failed me. I watched her at the video many times. Yeah, so it's a little backwards, and I put it on our page for the crash course because I wanted to have a little discussion on it too. So we'll have a little chat about it. So Andy, I'm glad you watched it. It's good for some things, but not all. So, but
yeah, I was doing it her way with the milli equivalents. I was doing it the way she was doing it, but I still kind of came out with the same answers, but I like this way better.
Yeah, this one's a little bit longer way, but when you don't do it as a full bag sometimes, or like your hospital has half-liter bags or 250-liter bags, you may run into some issues. So that's kind of what I wanted to talk to you guys about. So it is kind of in a good habit to know if you do that way, to also know how to do it this way too, just in case. So her way is not a horrible way by any means, but it's good to know, like, if you have to use different size bags, to know how to do it both ways. So I love her dearly. I love her at the videos and all of that too. So I'm old enough to know when it all started. But yeah, so great guys. Thank you for all coming and spending a bunch of time with me today and learning. I appreciate it, especially on the weekends. And I'll see some of you guys tomorrow morning, bright and early. And take care and have a great night.
Thank you so much for your
Bye,
time.
guys.
Thank you.
Thank you.
Of course.
Happy birthday, everyone.
Yeah, happy birthday.